Hey everybody, Mr. Fritz here. In this video we want to find all of the remaining 5 trig ratios given this one already and a little bit of information about this. So what we know here is that the cosecant of theta is equal to 7 times the square root of 13 over 13, and the cosine of whatever this mysterious angle is greater than 0. So we're going to dive into these big 6, and basically what we need to do is we need to find what x is, what r is, and what y is. And we're just going to kind of mix and match them to find all of these different ratios between these sides. So to start off, let's kind of visualize what's going on here. If I have a circle in my coordinate plane, it's going to look something like this. Not the best circle, but it'll do. And what do I know about this triangle that I'm kind of superimposing into my circle is that the cosecant is positive, since this is positive, and the cosine is also positive. And one thing that I'm kind of trying to keep in mind here is that the cosecant of theta is 1 over the sine of theta. So basically I'm saying that the sine is positive and the cosine is positive, which tells me that I'm going to be in quadrant 1 here. So it's as if I'm working with some sort of an angle that's somewhere in here, and what I want to do is I want to drop a perpendicular, and I'm kind of interested in what's going on with this right triangle here. So let's actually draw that right triangle. I'm going to kind of lift it right out of my unit circle. Or not my unit circle, but my regular circle. What do I know about this what I know about this circle is that the radius is 13. Since cosecant of theta is equal to the radius over y, what I know then is that the radius is actually this one, 7 times the square root of 13. This is my r, this is my y, this is my x. And so I'm going to label this radius as 7 root 13. I'm going to call this y equal to 13. And now the question is I need to find what x equals. So again, this cosecant of theta is r over y, so the r has to be 7 root 13, and the y has to be 13. So at this point I want to find x, and the way that I do that is I got to remember my Pythagorean theorem, and that states that the x squared plus the y squared of this triangle here, these two legs, is going to equal the radius squared, or the hypotenuse squared. So I'm looking for x. I don't know what x is, so x squared plus 13 squared is going to equal 7 root 13 squared. Let's go one step further. X squared plus 169 is going to equal, I did do the math for this one already, 637. That would be 49 times 13. And let's keep going up here. So this is going to, if I subtract 169 from both sides, I should get an x squared equals, I do forget this one. This is going to be 637 minus 169 is 468. So let's take the square root of both sides, find out what x is equal to, square root that, and we do come out with x equals, I can split this up into the square root of 36 times the square root of 13. Let me just double check that I remember these numbers. Yes, okay. So x is going to equal 6 times the square root of 13. And that's a big deal, because now that I know x, I already know what my y is, and I already know what my r is. So I'm going to take all 3 of these different angles. I'm going to take this guy, and this guy, and this guy, and I'm just going to pop them into my various trig ratios. So let's do that. Here's my x, my y, my r, and I'm just going to fill this out from this point onward. So the cosine of theta is equal to x over r, so that's 6 root 13 over 7 root 13. And what's nice about this is the root 13's cancel. See you later. And so this is going to equal, just 6/7. The sine of theta is going to equal the y over the r, so that's 13 over 7 root 13. And unfortunately, I don't like the root 13 in the denominator, so I do have to rationalize by multiplying by root 13 over root 13. So this is going to be 13 root 13 over 7 times 13. And I'm not even going to waste my time multiplying those together because they cancel out. This goes away. So my final sine of theta is going to be 13. Oops, I canceled the wrong things. This is what cancels, not the square root of 13. So the square root of 13 over 7 is my sine of theta. Let's keep going here. The tangent of theta is given as y over x. So that is given as 13 over 6 root 13. Once again, I rationalize. Times root 13 over root 13. So I get equal to 13 root 13 over 6 times 13. And this time I'm going to do it right. I'm going to cancel out the right thing. Let's cancel out this 13 and this 13. So the tangent of theta is going to equal root 13 over 6. Almost there. 3 out of 6. Okay, so now let's do the secant of theta. Secant of theta is the r over the x. So here's my r, 7 root 13 over my x, 6 times root 13. Root 13's cancel, and I get 7/6. Could have also said that that's just the reciprocal of cosine of theta. Either or works for me. The cosecant of theta, that's already given to me. So you know what? Boom, there it is, cosecant of theta. And then finally, the cotangent of theta is going to be the x over the y. So I've got 6 root 13 over 13. And that takes care of all 5 of these trig ratios. So seems like a lot of work, but really the grunt work was figuring out what this x value was equal to. Once we found that x value by solving our Pythagorean triangle, our right triangle, we basically just plugged stuff in and found those other 5 ratios. So there you have it. Hope this was helpful.